All right, let's dive straight in and unlock the absolute secrets of the Cambridge Computer Science examinations. Whether you are tackling syllabus 0417, 0478, 0983, 0984, 2210, or what we are heavily focusing on today, the 9618 AS and A-Level, you are in exactly the right place. We are zooming in specifically on multimedia, focusing entirely on bitmap image encoding. Now, I like to call the winning strategy we are going to use today the sculptor approach. Why? Because when you walk into that high-pressure exam hall, you are essentially starting with a massive, heavy block of raw data and ideas. The secret to a top-tier grade isn't about picking up that whole heavy block and throwing it at the examiner. No, it is about carefully, methodically chipping away the irrelevant information to reveal the masterpiece of a perfect, highly structured answer. Today, we are completely transforming how you approach this syllabus topic. Let's get to work.
Now, what's really interesting and frankly a little heartbreaking about this slide is it highlights a frustrating trap that the principal examiner reports are incredibly clear about. Let me paint a picture of two typical students for you. First, we have Alex. Alex walks into the exam, sees a question about bitmap image encoding, and panics. He just overloads his answer with raw computer science facts. He writes down literally everything he has ever memorized about pixels and color depth, but he completely fails to actually analyze the specific problem in front of him. Zero analysis. Then, on the flip side, we have Sam. Sam looks at the clock, rushes, and completely misses the command word requirements of the question. He calculates when the command word clearly said describe, or he describes when he was supposed to evaluate. These students lose incredibly easy marks, not because they don't know the computer science, but because they simply don't know how to play the exam game.
So, to make sure you never fall into the Alex or Sam traps, we have a very clear roadmap for today's explainer. First, core principles. Second, the method mark strategy. Third, top examiner warnings. And finally, evaluating algorithms. We will unpack the essential theories, give you a bulletproof exam framework, hand over warnings straight from the examiners themselves, and show you exactly how to expertly evaluate code.
Let's move right into Section 1, Core Principles. This is the absolute foundation of your mastery. And honestly, this is where we start talking about how to structure your thoughts using the PEL framework. Point, evidence, explanation, and link. Top students use this constantly. But hey, before we continue and really break down how to apply PEL to your core computer science theories, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, you want to be on board for what's coming next.
Okay, let's talk about building that conceptual framework. The crucial point here is that examiners demand absolute precision. A conceptual framework isn't just a random list of terms you frantically memorized the night before the paper. It is a robust theoretical architecture. That means you need incredibly precise definitions of things like color depth, image resolution, and file headers. You also need to deeply understand the causal relationships. For example, you need to be able to explain exactly how increasing the resolution causally and inevitably impacts the final file size of that bitmap image. And most importantly, you need syllabus integration. You have to connect these multimedia concepts to other parts of the 9618 syllabus. If you can do that, you're thinking like a sculptor.
And this brilliantly illustrates why memorization isn't enough. You must apply evidence-based reasoning to completely new scenarios. The Cambridge syllabus explicitly emphasizes that top-performing students exhibit a connected conceptual understanding. Look, the exam is almost never going to ask you a question that looks exactly like the practice problem in your textbook. They are going to throw an unfamiliar context at you. It might be a scenario about a specialized medical imaging device in a hospital, or maybe an image transmitted from a Mars rover with strange compression requirements. If you're like Alex and just memorized isolated facts, you will freeze up. But if you have that connected understanding, you can transfer your systematic analysis to entirely new, unseen problems.
Moving away from abstract theory, let's get into Section 2. This is the actionable mechanics. This is the method mark strategy, where we take those red pen marks you usually get and start transforming them into green check marks. Remember this golden rule. Write it down, etch it into your brain. Marks are awarded for the process. This is a massive relief, but it's also a very strict requirement. Think back to Sam rushing through his paper. When you are calculating the file size of a bitmap image or interpreting complex binary representations, you might make a tiny, silly arithmetic error at the very end. It happens to the best of us. But if you just write down the final wrong number, you get 0. However, if you lay out your data interpretation skills clearly, showing exactly how you extracted the binary data and stating the exact formulas you used, you secure those vital method marks. You are literally getting points for showing your thought process. Okay,
Let's dive into this standardized sequence which transforms complex data interpretation into a highly reliable toolkit. This is your survival guide, the ultimate computer science success blueprint. Step 1 is absolutely critical. Deconstruct the question. What is the exact command word? Is it evaluate, describe, calculate? Step 2. Extract the binary data. Pull the precise numbers from the binary representations given. Step 3. Select the analytical framework. Which specific formulas apply here? Step 4. Execute with clear notation. Write out your calculations step by step so the examiner can easily follow your logic. And Step 5. Present perfectly with correct terminology. I want you to imagine taking 60 seconds on your next past paper just to force yourself through these 5 steps before you even pick up your pen. It changes everything.
Now, when the question shifts to practical application and algorithmic thinking within Bitmap encoding, this step-by-step decomposition is your absolute best friend. You can't just guess at the code or throw a bunch of syntax at the page hoping something sticks. You need to carefully select the appropriate data structures, like 2D arrays, to hold your pixel data. You need to ensure efficient code implementation, and crucially, you must show rigorous testing to verify your results. Examiners want to see that you can think sequentially and logically.
Now, what's really interesting about this slide is that linking binary extraction to a vivid story drastically improves your retention. A lot of students really struggle to remember the sequence of steps for decoding a bitmap file header. It's dry, it's boring. So instead of rote learning, visualize it. Imagine a character walking through a grand library. The library itself is the file. First, they check the sign on the door. That is your file signature. Then they look at the directory map on the wall. That is your offset, telling you where the actual pixel data begins. Creating these vivid visual stories anchors these abstract concepts into your memory, making them instantly retrievable when you're sweating under exam pressure.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, welcome to Section 3, Top Examiner Warnings. It's time for our interactive workshop. Let's look at the pitfalls you need to avoid.
The principal examiner reports have explicitly identified 3 massive mistakes that consistently drain candidates' scores. These aren't just minor typos. These are fundamental flaws in exam technique that show up year after year across the globe. By knowing these 3 traps, you are already miles ahead of the competition. For our first interactive challenge, imagine I just put a complex data chart on the screen with a 60-second timer. Your goal isn't to read every number, it's to extract the core trend. That's the mindset you need for these next warnings.
Let's look at the first bullet. The classic trap is using the wrong formula or algorithm for the context. You might accidentally use a formula for sound compression when you should absolutely be using one for bitmap images. Second, and this is our find the flaw challenge for you to think about, forgetting boundary conditions and edge cases. What happens when an image is purely one single color? What happens if the dimensions are 0? If your written algorithm doesn't account for these extreme edges, it fails the examiner's test. And third, generic answers. If the question asks about an image taken by a Mars rover, your answer must reference the constraints of a Mars rover, like the severe limitations on transmission bandwidth. A generic, copy-pasted textbook answer gets 0 context marks.
And this brilliantly illustrates a simple fix. The examiner alert is flashing bright red right here. Candidates constantly confuse key terms. They mix up resolution and color depth all the time. They confuse lossy with lossless mechanisms. So here is your speed writing challenge. In an exam, you should take the first 30 seconds of an extended response to explicitly define your key terms using the point step of the Peel framework. This not only proves to the examiner that you know the theoretical architecture, but it acts as an anchor for your own thoughts so you don't stray off topic midway through your paragraph.
Finally, let's explore Section 4, Evaluating Algorithms. This is where we unlock the higher-order assessment objectives required for ultimate algorithm evaluation and reveal the final system.
Okay, let's dive into this table which maps out exactly how you must compare approaches and justify your algorithmic recommendations. Evaluating algorithm quality requires you to use specific metrics. You must identify time complexity,
Literally, how long does the algorithm take to encode the bitmap as the image size grows? You must identify space complexity. How much memory overhead does this encoding process require? And, as we just discussed, you must identify edge cases. When the command word asks you to evaluate alternatives, you must compare approaches using these exact metrics and clearly state their direct effect on performance. This is the evidence-based reasoning the syllabus absolutely demands for top marks.
Let's look at the before and after. Notice how a standard answer on the left will just state the facts about bitmap encoding in total isolation. It's dry, it's basic, it's what Alex would write. But the top-performing answer on the right makes brilliant cross-topic connections. It links the file size of the bitmap to network transmission speeds from an entirely different chapter. It links the encoding algorithm to hardware processing limitations. This proves to the examiner that you don't just have isolated pockets of knowledge, but a fully integrated conceptual framework. To hit that 100% mark potential, you need 3 rules: decode the command word, apply the Peel framework, and manage your time.
As we wrap up this explainer, the tools for mastery are right in front of you. Ask yourself, does your current study method actively account for boundary conditions and cross-topic connections? Students who implement these computer science strategies see an average improvement of 2 whole grade boundaries, but that is only if they practice consistently with our weekly videos. So here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Also, drop a comment below with your target grade for computer science and the biggest challenge you're currently facing. Our team reads and responds to every single comment. Like and share this video with your study partner. Remember, Ace the Exams, your Cambridge success starts here.